Alrighty, hello everyone. We have today, finally, I'm releasing the GPU version of the Excel Raytracer. And what I wanted to do was to give a little bit of an overview of what the model how the model actually works, rather than just kind of releasing it. Just to give people a feel for if they download it, exactly how to download it, where to put it. It's not as clear cut as the version that doesn't rely on any kind of external requirements, and I'll show you what I mean by that in a moment. So will require a little bit of hand holding, although it's very simple stuff at the end of the day. But what this model allows us to do, as opposed to what we looked at before, was this model actually runs off of the GPU. So what I've done, you'll notice that I've got this function over here. What this code actually runs behind the scenes via the GPU as opposed to the CPU, which is how Excel would always run its functions. It would always run its functions via the CPU. But what I've done is I've kind of gone into the internals of Excel, so to speak, and I've created my own function that basically allows you to do whatever kind of calculations you want through using the GPU. And that's not necessarily something I've seen done before much, so I really wanted to play around with that concept. There's no better way to play around with that concept than using something that's resource intensive like a Raytracer. And because I had already created a Raytracer, it was more of a matter of my kind of exporting those individual functions that I used to have, or individual formulae that I used to have in the Raytracing model, now over into this kind of like behind the scenes code. But the functionality of the model is almost exactly the same. So you'll notice we can animate as we had done before. So if you press the animate button, you'll notice this is running at about a frame a second, maybe a little bit faster than a frame a second. And this might be going slightly slower than usual because I've got the recording software happening at the same time. And given that this is running off of the GPU, the recording software will be taking up some of that capacity. But you can notice that kind of the scene is moving slowly. This is quite a lot of iterations need to happen for a complete kind of circle. So what I would usually do in this instance is kind of let it run for a while, record the whole thing, and then edit and speed up that recording. But you can clearly see that this guy's moving around, and that's all good. I'll stop this, and to stop you have to press escape and then just press end here. If we press play instead, that actually puts us in this kind of different scene, and we can move around using the W, A, S, and D keys to kind of move, the traditional forward, left, back, right. So we can move a bit forward here. And just to give a feel, the original Excel model that I created that didn't use the GPU, the size of the complexity of that model was way lower than what we have here. So what we have here is a much larger canvas. I think it's 4 times larger, if not more. And then for each pixel, you'll notice that you've got this kind of nice smooth shading happening. It's more complex calculations. You'll also notice that there's smooth shadowing over here. Again, that's more complex calculations. And there's more bounces happening in the scene. So the complexity is possibly 100 times more complex or more than the original Raytrace model. And this model's faster than the original model because we're going via the GPU. So it's pretty crazy stuff when the kind of complexity of calculations that you can get through Excel if you kind of are able to navigate your way through the kind of the code, the back-end kind of code, is it's pretty remarkable actually. So anyway, we can navigate the scene as before, and we can also rotate the camera So this is rotating to the left. This is kind of swiveling the camera to the left. Tilting the nose, you know. And then this is kind of rotating upwards. All that kind of stuff. We can just move back a little bit. And you'll notice that there's a little bit of kind of a weird set of pixelation happening here, where it's kind of not exactly black everywhere in the kind of quote-unquote sky area. And that is because there's a random number generation that happens alongside the traditional calculations. And that allows the scene that gives the scene a bit of noise. But what it also allows is for you to get this kind of the smooth shading to occur. And if you get enough randomization happening, you eliminate most of the noise, but you get this very nice smooth shadowing effect. Given that we're running off of Excel here, we can't eliminate the noise as well as we might want to, especially using the simple techniques I'm using, because there's just the complexity of calculations would it would be too much for what we're trying to do here. What that allows you to do is to get this kind of smooth shading and this kind of smoothness in your curves, and that really adds to the realism of the picture. And interestingly, if you think about a photograph, if you take a photograph in dark conditions, you get the same kind of noise. So it actually adds another level of realism to actually have the noise, rather than it being the super perfect kind of image. So that's, yeah, at face value, it might seem a little bit strange, especially compared to the original model that we looked at. But the level of realism it definitely adds to that feel. So what I'm going to do now is escape out of this, and you'll notice that down here in this part of the model, this just does some mathematics, and this is exactly the same set of mathematical calculations that was happening in the original model. And this is where macros come into play. As before, you have to have macros for any kind of keyboard input for Excel. There's no way to do keyboard input via formulae. So you have to use macros, and this is the only area where I effectively use macros in the whole thing. This is the entirety of the macro code. So it's nothing more, nothing less. Very simple stuff. For these keys, it performs some actions, and that's about it. So if I show you what those actions are, all it does is it basically chooses a different transform. So if you move forward, it will transform the camera by this matrix. The matrices are used a lot in 3D mathematics to perform the calculations in a very concise manner. So you use all these kind of different matrices to adjust the camera depending on which key the user pressed. And that kind of feeds through in this, relatively simple set of calculations. And if we just look at some of the other tabs for everyone's interest, on the Objects tab, we just have all the spheres that are currently in the world. And theoretically, we could move one of those. So this big sphere in the middle, I guess that's going to be the sphere with the largest radius, which is this guy. You'll notice there's a massive sphere here. That's actually the floor. The floor is actually a sphere. It's just a massive sphere. That's why there's a bit of an angle here, you can see. But yeah, we've got this guy. We could theoretically change the radius here to 3, and that should change the scene. So that's pretty cool. That means that this is clearly dynamic. You can adjust these spheres to any parameters you want, and it will have an effect on your scene. You know, so we could, this variable here could, and I'll just zoom in so you can see exactly what I'm looking at. But this variable over here lets you just change where the kind of how high that object appears. And so I think I've chosen the wrong one. So let's redo this. Let's just put that at 4, and you'll notice that this guy in the middle went up. Cool. So that's kind of what you get from this. And theoretically, I mean, some of these guys, you'll notice I've got some formulae here that just allow, as the kind of animation increases or decreases, these spheres will change in like their X, Y, Z coordinates will change. You could also change things like what the sphere looks like in terms of its coloring, as well as its radius. You could make the radius dependent on this parameter over here, which would be quite cool. So as you press animate, these spheres could grow and shrink. So that's things you could do over there. Yeah, so you'll notice the light source here. I think these are just hard-coded numbers, and I think these are actually hard-coded into the code itself. So I don't think they're actually, you can adjust these parameters if memory serves, and that's something I could make adjustable as we go forward. But it just kind of shows you the information about that light source. Here's a table of random numbers that I just generate and feed through to the code. This allows for that randomness that I mentioned in terms of that kind of noise that you see in the graphical display. And then you'll notice that the ray origin sits here, and this is basically the camera origin. This is where all the rays are shot out from into the scene. So that's a parameter or series of parameters that are needed for our big function over here, this RaytraceImage. And so that takes all the stuff from the objects tab that I've just walked through, and it also takes that matrix that I mentioned over there. So that's the entirety of the model. There's literally nothing else to discuss or describe about the model itself. There's a README tab if there's anything of interest. Some of this wording will change before the final release, but it just gives a little bit of a description as to how the model works. So the next piece that I'm going to describe is just how to set this model up on your own computer. Right, so what you're going to want to do is on the GitHub page that I link below in the description of this video, you're going to want to install it to or download it, I should say, to this exact folder on your drive. The reason why you need to do that is because this shader needs to be in an exact location. I haven't been able to figure out how to make it in a relative location so that you could theoretically copy paste this anywhere and then it would work. This shader needs to be exactly in this location for this model to work. So you might as well just throw everything into this file location and hopefully everything should work. If it doesn't, please give me a shout and I can try figure it out and take it from there. But basically there's only 3 files. There's the model, the Excel model itself. There's the XLL, which is basically what they call an Excel add-in. And what that Excel add-in allows you to have are new functions that you can call from Excel. So if you think about what the functions are here, it's just this one single function called RaytraceImage. But you could have any function you want, right? Like these functions are exactly the same as those functions like equals sum. You could create your own version of sum if you wanted to. And it could do the exact same thing as sum does, or it could do something slightly different, or whatever it is. Or you could create completely new types of formulae. And using the approach that I'm using, those formulae get calculated very, very quickly. So it's a pretty fun way to kind of speed up or improve the capabilities of Excel. So that's what's in this XLL file. And then what's in the shader file. Basically, shaders are the things that are run on the GPU. So this clearly demonstrates that we're using the GPU to do this, or this Excel model. So let's open up this guy. And this is the code that actually runs on the GPU. It's the coding language that's used here. I'm using OpenGL. So the coding language is called GLSL. And it's very similar to C or C++, a very simple version of C++. And at first glance, if you're not used to programming, this might look quite complicated. At the end of the day, it is relatively complicated because graphics programming is not the easiest type of programming. It requires a lot of knowledge of linear algebra, and it takes a while to get used to. It's easy once you get used to it, or quote unquote easy. But linear algebra is one of those things that until it clicks, it kind of doesn't make sense. Especially matrix kind of matrices, multiplying matrices against vectors and matrices against other matrices, and what the component parts of a matrix actually represent. It takes a long time to get a good feel for that kind of stuff. But once you do, actually this kind of, working these things out is relatively straightforward. So this is the kind of code that we use here to get the GPU working. And this all runs on the GPU. I'm more than happy to explain the component parts of this at some point. And but I don't think that's the purpose of this video for now. But just so you're aware, theoretically, if you really wanted to, you could start going and playing with some of these numbers, and it would actually affect the model. Now, how the model works is it actually reads this file every single time it loads this frame. So if you go and change this file, it will change what this looks like. It will change what is run on the GPU. So let's go over here and go and change. You can see the light location is hard-coded, as I mentioned before. It's these numbers, but they're actually hard-coded here. So if you change them here, nothing happens. But we could go and change it here. So let's get rid of that. And see what happens to our scene. So I'm going to save this file. And let's see what happens if we press F9. There we go. So the light just changed. So you can see that this, you can actually change what the GPU is doing by frame, per frame, by just changing that shader. All we needed to do there was just save that file, refresh this model by pressing F9. Or you could, do it while kind of these are animating. Or whatever, and you can change what your scene looks like. So I thought that was a pretty cool little example of kind of fun little things that you could do with the way that I've set this up, which is kind of fun. Alrighty, so this has basically hopefully been a helpful run through of how this all works. As I've mentioned. All you need to do is kind of download these files and have a go at using them. So I haven't mentioned one thing, and that is how to actually install an XLL file on when you've opened Excel. So I'll quickly demonstrate that now. Just before I mention that, as a general rule, don't trust XLLs, DLLs, or exe files that you download from the internet. I think that goes without saying, but I just want to throw that out as a disclaimer. That's kind of at your own risk when you download those kinds of things from the internet, if you're new to this kind of stuff. Because obviously anything to do with XLs, EXEs, DLLs, there's potential things that could be hiding in them that you don't know what they are. So just a huge word of caution there in the general sense for you to be aware. But if we open up here and we go options, if you go to add-ins, go to Excel add-ins, and I've already got this selected, but what you would do is you would press the browse button. So you'd press that browse button, and you would go to the folder where you've saved the information in this exact folder as I've mentioned, and you would just click on this guy. You press OK. I've already got it in here, so I'll just press replace. Yes, thank you. And it will show the Excel GPU demo ray tracing. Once that's loaded in, you'll be able to get an image here. If you don't have that XLL loaded, you won't get an image. Yeah, so be very cautious about making sure you do those steps correctly in order to be able to actually utilize the functionality of the kind of GPU functions. That is required for this formula to work. The other comment I would make, which I've put into the README, is if when you've kind of loaded up this file and Excel crashes, that means that for whatever reason the file isn't able to say find this shader, so it just flat out crashes. It doesn't throw an error, it just crashes your Excel. If you're getting that and there's no way to like remedy it, every time you open Excel, you might actually, or especially if you're opening up this model, you will crash Excel. So what you need to do is to open up a fresh instance of Excel just with a blank workbook and disable that XLL. And to disable the XLL, which is something you're going to want to do anyway going forward. You don't want this Excel sitting around there all the time. You just go straight back to this add-ins area. You go, and then you just untick that add-in. And if you press OK and you try run this guy again, you'll notice that now it doesn't work because it can't find that formula because we don't have the formula loaded in via the Excel, the add-in. But let me go back and demonstrate just adding that back in. So you'll notice that we get this little pop-up over here, which just shows you that we've got that GPU access. If we press enter here, we get the image back. Alrighty, so hopefully that was a good walkthrough of how this model works and how to get it activated on your computer, get everything up and running. If you have any questions on any of this, I'm more than happy to answer in the comments below. So you know where to find me. Not only that, but there's also the Discord channel. I lurk around there as well, so you can drop me any questions there. More than happy to answer. And I will be releasing a few more versions of this. So obviously not just doing ray tracing, there's all that other stuff that we can do as well. There's that n-body simulation that I demoed in my previous video. We're going to have a separate version, and so a separate model for that, as well as I'll probably do a separate video on that as well. And then there's well, now the world's our oyster, right? We've got access to the GPU. What else can we do in Excel with our newfound capabilities? So we will be exploring that in the future as well. So stay tuned. But yeah, in the meantime, guys, drop any comments or questions you have below, and yeah, I'll speak to you soon. Cheers.